Web 3.0 holds the potential to completely change the internet as we know it. We're seeing tons of people flock into this space to build the next generation of blockchain-based applications. And one industry that's primed for disruption is the music industry. And in this video, you're going to learn how to create a blockchain-based music player just like Spotify that's completely powered by Web 3.0 and NFTs. This is an amazing project to learn the fundamentals of blockchain development, how NFTs work, and to use for your portfolio if you're trying to land a high-paying Web 3.0 job. You don't have to be an expert to get started today. You're going to learn all the programming languages and skills as you go, like how to write the smart contracts in Solidity, how to write tests, how to make a website, and then actually how to put this project on a blockchain. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step-by-step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. And if you have been watching this channel for a while, then I want to introduce you to somebody who's going to help me make this tutorial today. So I've invited Ethan onto the channel to present on this topic. He's going to walk you through the entire process step by step. He's a total expert and he's going to do an amazing job explaining how this works and show you everything that you need to know. All right, so what are we talking about today, Ethan?
Yeah, so in this video, I'm going to show you all how to build basically a Web 3.0 Spotify clone, and the artist of the songs that are represented as NFTs will receive a royalty for each NFT that's sold.
Yeah, very cool. And I think this is going to be a big area where we could see some disruption in the music industry with Web 3.0. So I'm super excited to have a look at what we're going to build today. So let's get started.
Let's get a preview of the app we're going to build today in this tutorial. On the homepage, we have a music player that will allow us to listen to any of the music NFTs listed for sale. It works just like a regular music player. There is a play/pause toggle button, forward and backward skip buttons, but what makes this player different from a regular music player is that there's a button at the bottom that allows users to purchase the selected music token with Ether. And once you have purchased one, you can view it in the My Tokens page, where you can also play it, see the price that you purchased it at, and resell it using this resell form. So, let's say I want to sell it at a higher price, try to flip the NFT song. And when I do that, we can go back to the marketplace and you'll see that it's been relisted at the higher price. You can also go to the My Resales page and view it here under the listed. We can play the song as well here and view the price that we have it listed at. We can also view all the assets that have sold, and none are currently listed because no one has purchased the Icelandic Arpeggio NFT, but we could change that by purchasing it like so. Okay. Now if we go back to My Resales, as you can see, it's now listed as a sold asset. Here's a diagram of how the application will work. Let's first look at how a Web 2 music streaming app like Spotify works. So, whenever you use Spotify, you typically access it on a mobile device, and this mobile device talks to a web server. This is where all the code, user data, artist data, and audio files for Spotify is housed. And whenever you hit play on one of your playlists, a request is made to serve the corresponding audio files back from the server to your mobile device. This is how most music streaming apps are built, but it has a few downsides. For one, if you discover an up-and-coming artist that you think has a chance at becoming wildly successful in the future, Spotify or any other streaming platform does not provide a convenient way for you to bet on that artist's future success. Fans have to resort to collecting physical merchandise sold by the artist or attend their shows to support them. And from the artist's point of view, the revenue they generate from Spotify is based solely on the number of streams they receive, not on the magnitude of support they receive from their fans. For instance, the stream count for two artists may be equal, but the number of fans who'd purchase signed copies of their work could be substantially different. So we don't want to build a centralized music player website that disconnects artists from their most diehard fans. We want to build it in a decentralized way with a very different revenue model that best leverages fandom. So I'll show you what that looks like. Instead of having an application that talks to a web server, we're going to build a blockchain-based NFT music player application. You can access the application through a web browser with a blockchain wallet extension like MetaMask. The browser will talk to a website written in JavaScript, HTML, and CSS. The website will read and write data directly to the blockchain, where our code will be written in Ethereum smart contracts deployed to the Ethereum blockchain. And then all the audio files will get stored on a decentralized file storing system called IPFS. We're going to have a single smart contract that powers the entire application. It will serve two purposes. It will represent the collection of music NFTs and a marketplace whereby users can buy and resell them. In case you're unfamiliar with what exactly an NFT is, you can think of it as a unique digital asset. An NFT smart contract keeps track of the metadata of the NFT, which in this case is an audio file deployed to IPFS, a corresponding ID, and the address of the owner of the NFT. There's also special functions on the NFT contract that allows you to transfer your NFT to a different account and mint new NFTs. We're also going to add royalty fees to this main contract, such that each time a music NFT is sold, the artist of the music will receive the royalty payment. Now let's start installing the dependencies we need for this project, starting with Node.js. So you can install it directly from the Node.js website. And if you're not sure whether you have Node.js installed yet or not, you can open up a terminal and type the following command, node-v, then hit enter, and it should output the version of Node that you have installed if you have it installed. And for this tutorial, I recommend installing any version of Node between version 17.0.1 and 16.14.1 to avoid dependency issues. Next, let's go ahead and install the smart contract development framework we're going to use for this tutorial, Hardhat. Hardhat will allow us to write smart contracts in the Solidity programming language, write tests against them, spin up a local development blockchain, and deploy our smart contracts to it. Next, we're going to install Hardhat from our terminal using Node Package Manager, which came bundled with our installation of Node that we did a moment ago. So enter this command, npm install //save /dev hardhat. And for this tutorial, we're going to use a very specific version of Hardhat, so version 2.8.4, to avoid any potential dependency issues. So go ahead and hit enter. Next, we're going to install MetaMask, a crypto wallet browser extension that will turn our browser into a crypto compatible browser. So go ahead and go to the official metamask.io website, hit download now, then click install MetaMask for Chrome, go through the setup steps. And once you've completed that, go to your extension settings, browser extension settings, and ensure that MetaMask has been enabled. And you'll know it's been enabled once you see this box icon at the top right-hand corner of your screen. Alrighty, now that we've installed all the system-specific dependencies we need for the project, let's go ahead and start setting up the project. So instead of coding everything out from scratch, I'm going to use as a template this starter kit that I created. So go ahead and copy the URL to it, which you can find linked in the description down below. And once you do that, open up a terminal and then enter into the directory where you save all of your coding projects. So for me, that's in documents, development. And once you're there, we're going to enter the command that will clone the repository, which is git clone, and then paste in the URL, add a space, and then we're going to set the name of the project. So going to be music-NFTs, then hit enter. Next, we're going to enter into the newly created directory by typing cd music NFTs, hit enter. Then we're going to install all the starter kit's dependencies by typing npm install, then hit enter. Alrighty, once that's done, you'll know that the installation was successful. If you see added something packages, it's okay if you see some warning messages. As long as there are no error messages, then you know the installation was successful. Now, before we move on, we're going to need to install a couple more dependencies for the NFT music project that wasn't included in the starter kit. So if we go back to our application preview, we can see that each time we click on one of these navigation links, the app routes us to a new page. This feature doesn't come with vanilla React, so we're going to need to install the React Router DOM dependency to support it. So to install it, go back to your terminal and enter npm install React Router DOM at 6, then hit enter. Next, let's install the Identicon dependency, which we'll use to generate a unique Identicon for each music NFT. To install it, enter npm install Identicon.js, then hit enter. Lastly, we're going to add the Open Zeppelin smart contract library to our project. This is just a library of a bunch of secure pre-made contracts that developers can reference when they're building out a new smart contract, so they're not constantly reinventing the wheel or common patterns that developers often implement into their contracts. So we're going to use it to import the ERC 721 NFT standard. We're going to look at that more in depth once we get to it. To install it, enter the following command, npm I at openzeppelin/contracts at version 4.5.0, then hit enter. Alrighty, now that we've installed all the dependencies we need for the project, let's go ahead and take a tour of the project's source code. So to do that, go ahead and open up the project with a text editor of your choice. I'm going to use VS Code, and I'm going to do that from the terminal by entering code space dot, then hitting enter. So this is a Hardhat and React project combined into one. Inside of the source directory, we have two more subdirectories, a backend and a frontend. Inside the backend, this is where the smart contracts, or the smart contract rather, for the project will live, written in the Solidity programming language. We will also put the tests that we're going to run, written in JavaScript, to test the behavior of our smart contracts to ensure that they're behaving as we expect them. We're going to put that in the backend as well. And we also have this deploy.js script, which we're going to run to put the smart contracts on the blockchain, specifically the Hardhat development blockchain, which we're going to boot up from the command line. And we also have a front-end directory. This is where all the code for the client-side application will live. And we're using the React framework as the front-end framework to build out the client-side application. And you think of React as a component-based framework, and components are essentially just reusable pieces of code that have their own state management system at a high level. We're going to look more in depth at how React works once we start building out the client-side portion of the app. And we also have this package.json file, and it contains all of the project-specific dependencies. And as you can see, it has the React Router DOM, Identicon.js, and Open Zeppelin contracts dependencies, which we installed one by one manually. Then we have this hardhat.config file. And inside of here, we specify the version of the Solidity compiler we're going to use to compile our smart contracts, from human readable code to the code that the EVM understands, which is bytecode. We also specify where the smart contract inside of our project will live. And this may look a little unfamiliar to you if you've used hard hat before, that's because I'm manually configuring hard hat to look for the smart contracts right here and the tests right here, and to put the artifacts that are generated after each smart contract is compiled, and the cache as well, into the backend portion of the app as opposed to the default location, which is at the root of the project. Next, let's boot up the web server of the client-side application to ensure that everything was set up properly. So to do that, enter into your terminal npm run start and then hit enter. Alrighty, and that command should have opened up the website for the starter kit. So the code inside the front end portion that I showed earlier. And right now, the app.js component that we see rendered here is not connected to the blockchain in any way. Eventually, we do want to connect it to the blockchain, but before we do that, we have to finish building out the backend portion of the project. So we need to write the music NFT player contract, write test against it to make sure that it's behaving as we expect it to, and then we need to deploy it to a local development blockchain that will spin up with hard hat, and then we can start connecting the app to the blockchain and then modify the code in the app.js, the HTML and CSS code, to create the final product that you see here. So we have a lot of work ahead of us. So let's get started with building out the smart contract. Alrighty, first things first, let's go ahead and create a new directory inside this backend folder to contain our smart contract. So you can either do that from the terminal or by right-clicking this folder, creating a new folder, and then naming it contracts. It's up to you, but I'm going to do it from the terminal. So go ahead and open up a new terminal tab. So, like so. Then we're going to enter into the projects directory. And then, okay. Then we're going to type mkdir source backend and then contracts. Cool. And that created the contracts directory. So inside of here, we create a new file and I'm going to name it capital M music NFT marketplace. And the way we name Solidity files, we abide by a certain naming convention where we capitalize the name of the contract. And if there are multiple words in the name, we capitalize the first letter of that word with no space. So this is capitalize M, capitalize NFT, capitalize M, marketplace. All right, so at the top of the Solidity file, we're going to specify the SPDX license for the smart contract, as well as the version of Solidity the smart contract will be written in. Next, we're going to import two contracts from the OpenZeppelin library that our contract that we're creating will inherit. So we're going to import an ownable contract, which will give our contract special permissions to the deployer of the contract, or it could be any particular address. Then we're going to import the ERC 721 standard, NFT standard. So the ERC 721 standard essentially defines the set of all functions, external functions that a NFT contract needs to have. Okay, and this is a agreed upon standard by the Ethereum community. And the reason why we need this standard is that you want to ensure that all NFT contracts are compatible with other wallets and marketplaces that are in the Ethereum ecosystem. So, as well as other potential contracts that interact with NFTs. And it also saves developers a lot of time from having to reinvent the wheel each time they create a new NFT contract. They can just implement the standard and append the NFT contract where needed for their particular project. So here's the code of OpenZeppelin's ERC 721 contract that our MusicNFT contract will inherit, meaning that our contract will have all of this code inside of it. And essentially, what we will be doing when writing the MusicNFT contract is appending this ERC 721 contract to accommodate marketplace functionality, so buying and selling of NFTs, as well as royalty fees. The functions that our smart contract will interact with is this mint function to create music NFTs, and this transfer function to transfer NFT ownership for each marketplace transaction. So let's go ahead and create the music NFT smart contract. So we're first going to use the contract keyword, followed by the name of the smart contract, then the is keyword, followed by the name of each of the smart contracts that our music NFT marketplace will inherit. So the ERC 721 and ownable contracts. And then we're going to write some curly braces. And inside of these curly braces is where the code for the music NFT marketplace contract will live. Now let's declare some state variables. You can think of state variables as the storage of this smart contract. It's the data that's stored on the blockchain, the persistent data. So the way we declare a state variable is first defining the data type of the variable. So in this case, a string. And then we follow it up with the name of the variable. So base URI in this case. And between the data type and the name of the variable, we can also include a visibility keyword to specify whether we want this variable to be read by outside accounts. In this case, we do, so we use the public keyword. And then we use the equal sign followed by the value we're assigning to the variable, which is a URL that points to where all the metadata for the music NFTs are located on IPFS. So the reason why we have to specify the data type of variables in Solidity is that Solidity is a statically typed programming language, which means that the data type of variables cannot change. So for instance, I can't reassign this base URI variable a number or an address. It has to stay as a string. Now, the reason why we are specifying the base URI where we can find all the NFT metadata as opposed to assigning a separate URI for each NFT is that we know what the metadata will be for the entire NFT collection before we deploy the contract. Now, the way I generated this base URI is by first creating the JSON files that contain the metadata for each NFT, like I've done here, setting the name of each file to its corresponding token ID. After that, you're going to need to generate a single car file from them using this car.ipfs.io website. So click on this open file picker, then simply select the JSON files. Then go ahead and download the car file. And once you have the car file, you can use the NFT.storage app to upload the car file to IPFS. So and then click upload, choose file, downloads, then upload. And once it's been uploaded, you can copy the link to where you can access it on IPFS, like so, and then save that into your smart contract. I use this same app to upload the audio files for each NFT. Then I put the link for it on the audio field of the metadata, like this. Now, before I finish coding out the rest of this contract, let's go ahead and deploy it to the blockchain and then interact with it through the hard hat console to ensure that we've set up the backend portion of the project correctly. First, let's spin up a local development blockchain, which the hard hat framework provides us with. So to do that, go to your terminal and enter the following command: npx hardhat node, and then hit enter. Alrighty, and here is the development blockchain that's running from our terminal that we're going to deploy our smart contract to. As you can see, it comes with 10 accounts, and each account is funded with 10,000 fake ether. And here's the address of each account with the associated private key right below it. I should mention that whenever you spin up a new blockchain with Hardhat, it always generates the same 20 accounts. So these accounts are publicly known, and therefore you should definitely not use them to store real money, since anyone can gain access to these accounts and steal your funds. Alrighty, now that we have our local development blockchain up and running, let's go ahead and open up this deploy script and then add the code we need to it in order to deploy the MusicNFT marketplace. All right, now let's write the code that will actually deploy the MusicNFT marketplace contract to the blockchain. So first things first, we need to get the contract factory for the NFT marketplace. And the way we do that is by calling the getContractFactory method on the globally accessible ethers object that's injected into our Hardhat development environment. And we pass as input the name of the contract, so MusicNFT marketplace. So in case you're unfamiliar with what ethers is, it is just a JavaScript library for interacting with the Ethereum blockchain. And we're going to use it quite extensively to write tests against our smart contracts and build out our client-side application so that it's able to interact with the blockchain. You could think of the Ethers.js contract factory as an object that allows us to create the special transaction we need to deploy a particular smart contract to the blockchain. And we can do that by calling the deploy method on the contract factory. And it returns a promise that eventually resolves to an instance of the deployed contract. And we can use this instance to interact with the contract from within a JavaScript environment. Notice how we have to use the await keyword for each of these function calls. This is because each of these functions interact with the blockchain, and the blockchain is slow, so they each return, rather than getting the blockchain data immediately, it returns a promise, and we have to await for that promise to resolve before assigning the blockchain data to each of these variables. After that, we're going to pass the smart contract instance and the name of the contract to this save front-end files function, which saves a copy of the smart contract address and ABI to this front-end directory so that our client-side application can access it. And the reason why it needs to access it is that it needs these two pieces of information, the smart contract address and the API, to generate an instance of the already deployed MusicNFT marketplace contract. Alrighty, and that completes the deploy script. Now let's go ahead and run it. To do that, go back to your terminal and open up a new terminal tab, because now we have two different processes running in the main terminal window. So we have the web server running in one tab and the local development blockchain running in another. So let's get a fresh tab going. Enter back into the projects directory. Okay. And then we're going to write the command npm run deploy, then hit enter. Oh no, and we have a compilation error. Darn it. So I know why. It's because we need to call the constructor function on the inherited ERC721 contract. You could think of the constructor function as a special function. It's only executed once immediately after it's been deployed to the blockchain. So to call the constructor function on an inherited contract, we first pass to that inherited contract the argument of the constructor function. And we do that by first writing some parentheses after the name of the contract, and then we pass into those parentheses the arguments for the constructor function. So the ERC721 constructor function accepts a name and a symbol argument. So this will set the name of the NFT collection as well as the symbol of the NFT collection. So for the name, we'll pass Dapp, and for the symbol, we'll pass EAPP. Oh, and I almost forgot, before we run the deploy script again, we need to log the address of the NFT marketplace contract to the console so that we can create an instance of it inside the hard hat console. So let's go ahead and deploy the contract. We're running the deploy script, npm run deploy. Sweet, and it worked. And here's the development account that deployed the contract. And by default, this is the first account listed. And we also have logged the account balance, which is 10,000 Ether, and the deployed smart contract address. Now, let's go ahead and enter into the hard hat console by typing npx hard hat console. Then we have to specify the network that we're going to interact with. Localhost. So network localhost. And all this hard hat console is just JavaScript environment for interacting with the blockchain and any smart contracts deployed to it. Let's first fetch the MusicNFT contract, like so. Await. And then we're going to call the get contract at method on the globally accessible ethers object. And then we're going to pass to it first the name of the contract. So MusicNFT marketplace, followed by the contract's address in quotes. So we'll copy that from here, then paste it. Okay. And then hit enter. Awesome. It says undefined, but we can log the output by typing contract and then hitting enter. Sweet. So here are all the externally accessible functions, essentially the interface of the contract. So these are all the different functions that we can call on it. Let's go ahead and call this base URI function to fetch the base URI. So we can do that by typing const URI await contract base URI and then hit enter. Okay, type URI and enter. Sweet. And here is the URI that we assign to the base URI state variable inside of our contract. Awesome. Now let's fetch the name and then the symbol. of the NFT contract. So like this, name await contract dot name, sweet, Dapp. Awesome. That's what we expected. Now let's do the same thing for the symbol, like so. Replace name with symbol. Okay. Then hit enter. And symbol. Awesome. DAPP, all caps. Awesome. So that completes the first smoke test. We've got this deploy script working so that when we run it, it deploys our smart contract to the blockchain. And we've interacted with it from the hard hat console, reading each state variable on the contract. So the next thing we want to do is continue coding out the rest of the smart contract. And as we build out each functionality, we're going to write an automated test for it. This will prevent us from having to use the hard hat console over and over again to test the behavior. We're just going to write a test script that will do all that stuff for us when we run it. That will help to speed things along significantly. So let's get a quick review of how the contract will work before we continue coding it out. So this contract will represent a collection of audio files as NFTs. We can think of the audio files as songs in an album. We already know what songs will make up this entire album. For this project, I'm using 8 different songs, so we can mint them all upon deployment. This contract will also function as a marketplace. So after we mint them, we're going to list them for sale as marketplace items. And after we have written the code that handles this initial setup of the contract, aka the deployment, we will create the functions that fans will interact with, which will include the buying of music NFTs and the reselling of them. And we want to program these functions in such a way that the artist who dropped the album receives a royalty fee for each sale. So let's get started. So we need to include a few more state variables inside this MusicNFT marketplace contract. So that'll include the file extension of the metadata, so .json, and as well as the address of the artist so that our contract knows which account to pay the royalty fees to. And we also need to know the amount of the royalty fee. The address data type in Solidity represents an Ethereum address. You could think of these addresses as auto-generated usernames that identify both externally owned and smart contract accounts on the Ethereum network. The uint256 data type represents unsigned integers, so positive integers, that take up as much as 256 bits of storage. Next, we're going to define our own custom data type to represent market items. We can do that in Solidity using a struct. So to define a struct, we first use the struct keyword, followed by the name of the struct, then curly braces. Inside these curly braces is where we set each data field of the struct. So for the market item, that will include the token ID, seller, and price. And in order for the seller address to receive an Ether payment, we need to mark it as payable. Also, we need to define an array of type market item to contain all of the market items. Now let's create a constructor function. So as I mentioned earlier, the constructor is a special function that's called only once upon deployment. To define it, we use the constructor keyword, followed by parentheses, inside of which we define the arguments of the constructor. Then, the code of the constructor is contained in these curly braces. In the constructor, we're going to initialize the royalty fee, address of the artist, and the price of the music NFTs. So we're going to need to pass as inputs to it a royalty fee, artist address, and an array of prices. To avoid naming conflicts between arguments and state variables, we name each argument with an underscore at the beginning. We're also going to mark this constructor as payable so that the deployer can send the required ether upon deployment to cover the royalty fees for listing the NFTs on the marketplace, since the deployer will be the initial seller of each. And then inside the function body, we're first going to use the require statement to ensure that the ether sent, which we can reference using msg.value global variable, is enough to cover the royalty fee for each token listed on the marketplace. And we can calculate that amount by multiplying the prices.length times the royalty fee. And prices.length represents the number of elements in the array, which should equal to 8. Next, we're going to initialize the royalty fee, artist, and then create a for loop that iterates through all of the elements inside the prices array. Inside the for loop, we're first going to ensure that the price is greater than 0. Then we're going to mint the NFT for this address, setting the NFT's token ID as the current index. I'm going to pass those two values to the mint function that we inherited from the ERC721 contract. And then we will add the freshly minted NFT to the market items array using the push method. And for the push method, we pass in a freshly initialized market item struct. So the way we initialize it is by using the market item keyword, so the name of the struct, then we pass in the values we want to set for each field of the struct. So for the token ID, we set the current index, and for the seller, we set it as the deployer, which we can reference using the msg.sender global variable. So that's the account that called the constructor. And then we cast it as payable. And then for the price, we set it as the element at the current index in the prices array. Alrighty, and that completes the constructor function. Now, let's write the test script to test it out. So let's go ahead and make the directory that will contain the tests. So inside this backend folder, go ahead and right click it, then click new folder. And we're going to title this test. Okay. And then inside of here, we're going to create a new test file. We're going to call it MusicNFT marketplace.test.js. Then hit enter. So we're going to be using a few different tools to write our smart contracts. For our testing framework, we're going to use Mocha, which will allow us to write organized test cases, and it runs on the back of Node.js. And we're also going to use the Waffle and Chai assertion libraries to compare return values with expected values. So first things first, we're going to import the Chai assertion library at the top of our testing file. We don't have to import Mocha or Waffle because Hardhat injects those two into our testing environment automatically. So to start things off, I'm going to paste in some boilerplate code. So this code essentially does the exact same thing we did when we ran the deploy script and then interacted with the contract from the truffle console. So inside this before each hook, we deploy the contract in the same way we did inside the deploy script, except this time when we call the deploy method on the factory, we pass in the constructor arguments, which includes the royalty fee, address of the artist, and the array of prices. We can also send the ether needed to cover royalty fees by passing a metadata object as the last argument, setting the value property as the deployment fee. We then fetch the name, symbol, and base URI from the contract, just like we did from the hard hat console, and then check to make sure that it equals to the expected value. I should also mention that because you can't represent decimals in Solidity, only integer values, we need to convert any values that represent ether to the smallest subdivision of ether before we pass them as input to our contract. The smallest subdivision of ether is called way, and 1 ether is equal to 10 raised to the 18 way, or 1 followed by 18 zeros way. We can use the parse ether method to easily convert units of ether to units of way. So for the royalty fee, prices array, and deployment fees, we need to represent all of those values in way units when passing them to the constructor. So let's go ahead and finish testing the deployment of the contract. So it should track the name, symbol, URI, as well as the royalty fee and artist. Okay. And that'll look like this. So we just call the royalty fee method on the contract, and then ensure that it equals to the royalty fee variable we set up here, and essentially do the same thing for the artist. Oh, and by the way, we can get the development account on the local blockchain by calling the getSigners method on the ethers object, and it returns an array of all of the development accounts. And we're going to set the first account as the deployer, the second as the artist, the third as user 1, and the fourth as user 2. Next, let's test that it mints then lists all the music NFTs. So first, we're going to check that the NFT balance of the contract is equal to 8. Next, we're going to check that all the market items are correct by first mapping through the prices array, passing an asynchronous callback function that first fetches the item, then checks that the item's fields are all correct. And because we're passing an asynchronous callback to the map array method, we need to cast it in a promise.all method to wait for all of the asynchronous calls to resolve. And lastly, we need to check that the ether balance is equal to the deployment fees. So we can do that by calling the getBalance method on the ethers provider, passing the address of the contract, and then we ensure that it's equal to the deployment fees variable. Awesome, and that completes the deployment test. Now let's go ahead and run them. So go back to your terminal, and if you're still inside the hard hat console, you can exit out of it by typing the .exit and then hit enter. Alrighty. Now, to run the test, we need to type the following command, npx hardhat test, and then hit enter. Sweet, and everything passed. Awesome. Alrighty, now let's go back to our contract and then create a function that will allow only the owner to update the royalty fee. So to do that, we first need to define a function, and we could do that using the function keyword, followed by the name of the function. And then in parentheses, we pass the arguments of the function. So in this case, the updated royalty fee. And then we set the visibility of the function with the visibility keyword. So we're setting it as external, which means that only outside accounts can call this function. And then we apply the only owner modifier to the function, which we have access to from this ownable contract that we've inherited. And what this modifier does is that it checks that the account that is calling this function is only the deployer of the contract. And after that, inside the function body, it simply updates the royalty fee state variable. Alrighty, now let's write the test for this update royalty fee function. So we're going to describe updating royalty fee, and only the deployer should be able to update royalty fee. Okay. Now we first call the update royalty fee function. Then we call the update royalty fee function again, except this time the user account calls it instead of the deployer. And the way the user calls it is that we have to first connect the marketplace, NFT marketplace contract with the user one signer. So we do that by calling the connect method on it, passing in the user one. And we expect that it's reverted with ownable caller is not the owner. And after that, we check that the royalty fee has indeed been updated and is equal to the fee value that we passed into the update royalty fee function. Alrighty, now let's run the test again. Sweet, everything passes. Now let's start creating the function that will let fans purchase music NFTs. So this function will accept token ID as an input, and we're going to mark it as external as well as payable. And inside the function body, we're going to assign the price of the market item, a local price variable, and we're going to do the same thing for the seller of the market item. And then we ensure that the ether sent with the call to the buy token function is equal to the asking price of the item. And then we update the seller field on the item to the 0 address, since no one is selling the item anymore. It's been purchased. And then we transfer the NFT from this address to the address that called the function, aka the buyer. And then we pay the artist the royalty fee by calling the transfer method on the artist's address. And we do the same thing for the seller, except we pay them the ether that the buyer sent with this function call. Lastly, I want this function to emit an event. Now, an event allows us to log data to the Ethereum blockchain, and you can use them as a cheap form of storage or to update user interfaces of dApps when listened for. So let's go ahead and define a market item bot event at the top of the contract right here. Then we're going to emit it at the bottom of this function. So to define an event, you first use the event keyword, followed by the name of the event, then parentheses, and inside of these parentheses, that's where you define the different fields of the event separated by commas. So for the market item bot event, we're going to log to the blockchain token ID, the seller, the buyer, and the price of the purchased item. And then we're going to set the token ID and seller fields as indexed. And this will allow us to search for market item bot events with the token ID and seller fields as filters. Then we're going to emit the event like this, passing in the token ID for the token ID field, the seller local variable for the seller, the buyer, the account that called the buy token function, and the price field we're going to set to the price of the market item. So first things first, we get the initial ETH balance of the deployer and artist account by calling the get balance method on each of their accounts. Then user 1 calls the buy token function on the contract, purchasing the first music NFT. So the music NFT at index 0. And then we check that the market item bot event was emitted with these arguments. So for the token ID, it's 0. The seller is the address of the deployer. The buyer is the address of user 1. And the price is the first price in the prices array we defined up here. After that, we get the final ETH balance of the deployer and artist. Then we check that the item's seller field should be the 0 address. Then we check that the seller received the payment for the price of the NFT sold. And then we check that the artist received their royalty payment and that the buyer is now the owner of the NFT. And then for the fail case, user 1 tries to buy the token, except this time they send the incorrect price. So they send the price for the second item, so the item at index 1, and we expect it to be reverted with please send the asking price in order to complete the purchase error message. Sweet, and that completes the buy tokens test. Now let's run it once again. npx hardhat test, hit enter. Sweet, everything passed. Alrighty, now let's write the last function to complete the marketplace functionality of our smart contract. So first we check that the user submits the royalty fee. Then we check that the price the user is trying to resell their token at greater than 0. And then we of the market item that is being resold to the price argument, and we set the seller field as the account that's calling the resell token function, casting it as payable. And then we transfer the NFT from the user to this contract. And lastly, let's go ahead and emit a market item relisted event. But first we need to define it like we did the market item bot event. So that will look like this. So it's basically the same as the market item bot event. All the fields are the same except we don't have a buyer field. And then we're going to emit it like this, passing the token ID argument as the token ID field, the account that called the resale function as the seller, and then the passed in price for the price field. Alrighty, now we're going to create the test for reselling tokens, and we're going to have this for each hook, which makes it such that user 1 purchases an item before we run either of these tests. The first test checks for success conditions. So should track resale item, increase ether balance by royalty fee, transfer NFT to marketplace and emit market item relisted event. And the second should test the fail case. So should fail if price is set to 0 and royalty fee is not paid. So first we create a resale price variable and assign it the value of 2 ether, convert it into Wei. And then we fetch the initial NFT marketplace balance, or rather MusicNFT marketplace balance. And then user 1 lists the NFT for the resale price, hoping to flip it and double their money. And then we check that a market item relisted event was emitted with these arguments of the token ID, 0, the seller is the user 1 address, and the price is the resale price. Then we get the final balance of the contract. And next we check that the final market balance is equal to the initial marketplace balance plus the royalty fee. And then we check that the owner of the NFT is now the marketplace contract. Then we get the item from the items mapping and check that the items fields are correct. So that the token ID is equal to 0, seller, user 1 address, price, resale price. And for the fail case, we check that it's reverted when the price is set to 0. So price must be greater than 0. That's the error message we expect. And then we check that it fails when the royalty fee is not paid. So we're setting that the value is 0. And we expect the error message to output must pay royalty. Alrighty, and that completes the reselling tokens tests. So let's run the test script. See if everything's working as it should. Sweet. All the tests passed. So at this point, we have completed the marketplace and royalty functionality of the smart contract, but there are a couple more functions that I do want to add. Now, these functions are not going to update any of these state variables, so they're not going to cost any gas, but rather they're going to fetch data from this smart contract. Specifically, we're going to write one function that's going to fetch all of the market items that are listed for sale. And then we're going to create another function that fetches all of the tokens or the items that the user owns. So let's focus on this get all unsold tokens function first. So we're going to mark it as view because it's not modifying any state variables. It's only reading them. And then we're going to say returns some data, and that data is going to be of type market item. It's going to be a market item array. Inside the function body, we first fetch the unsold count by calling the balance of function, passing in this contract's address, and that'll get the number of NFTs that this contract owns, which represents the unsold count. And then we create a new in-memory market items array. And whenever you create a new in-memory array, it has to be of fixed length, and we specify the fixed length in parentheses like so. And we're going to set the length equal to the unsold count. And then we create a new local variable, a current index, and then we're going to create a for loop that loops through all of the tokens in the collection. And then inside the for loop, we have an if statement that checks if the token seller is not a 0 address. And if that's the case, then we know that that market item or token, I'm using the two terms interchangeably, I hope that's not too confusing, has not been sold yet. It's unsold. It's still listed on the marketplace. So we can assign that market item to the element at the current index in the tokens array, and then we iterate the current index value. And after that, once the for loop has ended, this in-memory tokens array will contain all of the unsold tokens. And then we can return them, like so. Alrighty, and that completes the get all unsold tokens function. Now let's focus on the get my tokens function. So this function is going to function in the same way as a get all unsold tokens functions. I'm using the word function a lot here. But yeah, so the only difference is instead of fetching the unsold count, we're going to fetch the user's token count, which we can, so instead of passing the contract's address to the balance of function, we're going to pass the user's address. And instead of checking if the seller field on the market item is not equal to the 0 address, we're going to determine if the owner of the token is equal to the user. Alrighty, and last but not least, we need to include one more function. This is an internal function, and it's going to override the base URI function that we inherited from the ERC 721 contract, so that it returns the base URI state variable that we have defined up here, like so. Alrighty, and that completes the entire MusicNFT marketplace contract. You should definitely give yourself a nice pat on the back right now. You've come a very long way in this tutorial, and all that we have left for the back end is just to finish up the test by writing the test for these two getter functions, and then we can start building out the front end part of the project. So we're describing getter functions, and in the before each hook, user 1 will purchase item 0, and user 1 will also purchase item 1, and then user 2 will purchase item 4. And we have created variables that store the IDs of the sold items, the items owned by user 1, as well as the items owned by user 2. So for the first test, we're going to check that the get all unsold tokens function fetches all the marketplace items up for sale. And we do that by first calling the get all unsold tokens functions on the marketplace, assigning that to unsold items variable. And then we check to make sure that all the returned unsold items have filtered out the sold items, like so. And then we compare the length of the unsold items array to the prices length minus the sold items length, and we expect this to evaluate to true, since the number of unsold items is equal to the total number of items in the collection minus the sold items. And then for the get my tokens test, user 1 will call the get my tokens function, and that will get all of their items. Then we check that the returned my items array is correct, and that the owned by user array length is equal to the returned array length. And then we essentially do the same thing, but for user 2, we get all of user 2's items. And then we check that the returned items array is correct, and then we compare the lengths. Oh, and by the way, this code and this line of code might seem a little confusing. All it does is check if the elements contained in the my items array is also contained in the owned by user array. And then this line of code checks that none of the items in the sold items array are in the unsold items array. Now let's run the entire test script for the last time to ensure that we have. Alrighty, and that completes the final test. Now let's run the entire test script for the last time to ensure that we have our entire backend totally complete. So let's go ahead and do that. npx hard hat test. Hopefully everything's working first time around. Awesome. Everything passed. Now we can finally start building out the front end. Alrighty. So now let's go ahead and deploy the completed smart contract to the blockchain. But first things first, we need to modify this deploy script so that it passes the arguments for the contract's constructor to this deploy method. So we can do that pretty easily by copying the code we use to deploy the contract in the test and then replacing it with this code, and then set the second development account as the artist account. And then we can copy the royalty fee, prices, and deployment fees variables that we defined in our test script into our deploy script, like so. We also need to copy and paste the two-way function that we defined in our test, which converts ether units into way units, like so. Awesome. Now let's go ahead and run the deploy script. PM run deploy and hit enter. Sweet. We've successfully deployed the completed smart contract to the blockchain. Oh, by the way, I should mention that this npm run deploy command is a command line shortcut that I've configured inside of this package.json file right here, and it executes this much longer command. So yeah, if you've used hardhat before and were confused by that command, that's where it's coming from. Here's the starter kit we began the project with. We're going to spend the rest of the tutorial modifying its source code to turn it into the final project that you see here. So to do that, the first thing we need to do is connect it to the blockchain. But to connect to the blockchain, we first have to connect our browser to the blockchain. We can do that by importing the accounts on our hardhat development blockchain into MetaMask. But before you do that, make sure to add hardhat to the list of available networks on your MetaMask. If you haven't done that yet, click this drop-down oval button, then click Add Network, and then you're going to fill out all of these fields with this information. Alrighty, once you've done that, head on over to the Terminal tab where you have your development blockchain running. Go ahead and copy the private keys for account number 2 and account number 3, and then import them into your MetaMask. Now, the reason why we're importing account number 2 and number 3 is that these two accounts will represent the users of the app, while account number 0 represents the deployer, and account number 1 represents the artist account. Alrighty, so go ahead and copy the private key for account number 2, then click the MetaMask icon, and then click this circle icon at the top right, then hit import account, and then paste in the private key, hit import, and then do the same exact thing for account number 3. Alrighty, now that we've connected our browser to the blockchain, let's connect our client-side app to it. So go ahead and locate the app.js component. You can find that in the front end components directory. Open it up. Alrighty, so to speed things along, I'm going to paste in some boilerplate code into this app.js file. All this code does is render our navbar and links the navigation links in the navbar to the route of our app using the React Router DOM dependency that I have imported here. For the front end part of this tutorial, The main focus is on connecting our client-side website to the blockchain, not on designing the UI of the app with HTML and CSS. If you'd like to know more about how this boilerplate code works, you can check out the other tutorial I made where I built an NFT marketplace like OpenSea. We're going to import the useState hook from React, which will allow us to create essentially a mini database on our front-end website. We're going to use the hook to store the account that's connected to the app so we can render it in our nav bar. We also need to know when data is being loaded from the blockchain so we can display a loading page instead of the contents of the app. So we're going to put that in the state as well. The way useState works is that it first returns a variable we can use to reference the stored value in our app, and a setter function that updates the returned value by passing the updated value to it. We also pass to the useState hook itself the initial value of the stored variable. So the value of the variable before the setter function updates it for the first time. So for loading, we're going to set it initially to true and account null. Okay, so let's go ahead and create the function that will connect our client-side app to the blockchain, which we're going to call Web3 handler, and then fetch the MusicNFT marketplace smart contract deployed to it. So we're going to use the ethers library, which we've imported up here, to create this connection in the same way we used it inside of our test and deploy scripts, except this time, ethers is going to connect to MetaMask, and MetaMask is already connected to our hard hat blockchain. So ethers will use MetaMask as its Ethereum provider. There are many different types of providers, but the provider offered by MetaMask is called a Web3 provider. So that's the one we're going to connect to. The way we do that is by instantiating a new Web3 ethers provider and pass in the globally accessible window.ethereum object, which is injected into the browser by MetaMask. We also need to get the account that's connected to the app, and we can do that by calling this request method on the window.ethereum object, and this returns an array of accounts, and all these accounts represent all the accounts inside of the user's MetaMask wallet, but it's the first account in this accounts array that represents the account that is connected to the app. So we're going to pass that to the setAccount function. Now, in order to fetch the MusicNFT marketplace contract from the blockchain, we need to get the signer of the account that's connected to the app. And we can do that by calling the getSigner method on the provider, which will return a signer. And then we can pass that signer to this load contract function that I have defined below the Web3 handler function. Next, let's go ahead and add another stateful value that will store the contract, because eventually we're going to pass the contract to a home, my resales, and my tokens components, which we're going to create once we're finished building out this app component. Next, let's go ahead and get a deployed copy of the contract. And we can do that by instantiating a new ethers.contract object, and we pass into it the address of the contract, as well as the ABI of the contract and the signer. All right, now let's go ahead and import the contract's ABI and address from this contract's data directory. And this contract's data directory is created from the save front-end files function inside of our deploy script. So each time we run the deploy script, a new contract's data directory is created with this information. Alrighty, and then we set the contract state and set the loading state to false. Alrighty, now that we have created the function that connects our app to the blockchain. Let's take a preview of our app. So let's test out the navigation links, see if it routes us to the correct URL when we click it. Let's click my tokens. Awesome. Then my resales. Sweet. And then back to home to reset it. Awesome. Okay. Now let's go ahead and click this connect wallet button, which will trigger the Web3 handler function that we just created. Okay. Sweet. And we choose which account to connect with. I'm going to choose account 2. Okay, connect. Sweet. And now our app is connected to the blockchain with account number 2. Alrighty, so the next thing we want to do is build out the components for each of these navigation links, starting with the home link. Alrighty, so let's go ahead and create a new JavaScript file for the home component, like so, new file, home.js. And just like with the app component, I'm going to paste in some boilerplate code into this home.js file. So this home component needs to fetch all of the unsold music NFTs. And in order to do that, it needs access to the music NFT marketplace contract. So we're going to set it as a property of the component like this. And because this component is fetching data from the blockchain, we're going to keep track of when it's loading. And when it is loading, we're going to return a loading page. So let's go ahead and define the useState hook that will store the market items, as well as the function that will fetch them. So first things first, we need to call the getAllUnsoldTokens function on the contract to fetch all of the unsold tokens. And then we're going to map through the unsold tokens, assigning the returned array to a market items variable. Inside the callback, first we're going to get the URL of the current token by calling the token URI function on the contract. And then we're going to use the URI to fetch the NFT metadata stored in IPFS using JavaScript's fetch API. To do that, we pass in the returned URI plus the file extension, so .json, and then that'll return a response, and then we call the .json method on the response, and that will eventually return the metadata. And once we have the metadata, we can use that to generate an identicon, which is that unique icon associated with each music NFT that's generated. And the seed we use to generate each identicon is the metadata name plus the metadata price. And then we return an item object that combines the price of the item's ID, the metadata of the item, so the name, and the link to where the audio file of the NFT can be found on IPFS, as well as the identicon. Alrighty, and once we have all the market items, then we're going to store them on the state by passing the market items array to the set market items function. And then we set the loading to false. Sweet, and that completes the load marketplace items function. Now, we want to make it such that each time this home component is mounted to the DOM, which means that someone refreshes the page or they route back to the home page, then we want the load marketplace items function to be called automatically. And we can do that using the useEffect hook. So that's going to look like this. Now, this useEffect hook accepts a callback function, and this callback function is called each time the component updates, and it updates each time the stateful values change or update. So each time loading changes, the use effect hook is triggered, likewise with market items. And it's also triggered whenever the home component is mounted. Now, we only want to load the marketplace items when the component mounts, not when it updates for changes in loading and market items. So to do that, we're going to say if market items is null, then we're going to call load marketplace items. That's what this line of code does. And this works because the only case in which market items is null is when the home component is being mounted. Alrighty, now let's create the function that will allow users to buy music NFTs, like so. And this will be an asynchronous function call, and it'll accept an item value as a parameter. And inside the function body, we're going to call the buy token function on the contract, passing in the item ID for the value price of the item. And then we're going to load the marketplace items again, we're calling the load marketplace items function. But before we call it, we want to ensure that the transaction to buy the token completed. So we can do that by calling the wait method on the transaction response, which will wait for transaction receipt to be returned. Awesome. Now let's start building out the user interface of the home page. So let's go down to this final return statement. And first we're going to check if the market items length, so market items array length, is greater than 0. And if it is, that's where we're going to display the music player. And if not, then we're going to say no listed assets. Alrighty, now let's add a couple more pieces of data to our state that we need to build out a functional music player. So that's going to include an is playing value. So we need to determine when a music NFT is being played or not, as well as the current music NFT being displayed. So that's going to include an is playing value to determine if a music NFT is being played or not, as well as the current music NFT that's being displayed by the player. And we also need to use the use ref hook to keep a reference of the music NFT's audio so that we can control when to play and pause it. We also need to use the use ref hook to create a reference of the music NFT's audio file so that we can control when to pause and play it. Awesome. So moving on, we're then going to render the audio file of the music NFT using this audio tag, setting the source as the audio link on the market item that's currently being displayed. And then we set the reference to it. And then below it, we have the music player represented as a React Bootstrap card. And inside the card's header, we keep track of the current music NFT's number and the total number of music NFTs. And then we display the image associated with the music NFT, which we've generated as a identicon. And then we have a card body inside of which we have a card title. And that is where we display the name of the NFT. And below the card body, we have a card footer. And that's where we have a button that displays the price of the NFT. And we have to convert that from Way to Ether using the format Ether method on the ethers.utils. And then for the onClick attribute, we pass in a callback function, which triggers the buy market item function that we created up here. And it passes the current market item as an argument. So inside of this card body and below the card title is where we're going to place the music player controls. So the skip forward and backwards button, as well as the toggle play and pause button. But before we render out the interface of the music player controls, we first need to create the functions that it'll interact with. First, let's create the function that the skipping buttons will trigger each time they're clicked. So we're going to tell this function skip song. And if the forward skip button is clicked, then we're going to pass true to the skip song function. And if the backward skip button is clicked, we're going to pass false. So let's first handle the skip forwards case. So when that happens, we're going to want to update the current item index. So we're going to call the set current item index function. We're going to pass in a callback. And inside that callback, we're first going to create an index variable, assigning it the current item index. Then we're going to increment it, so increase it by 1. And if the index is greater than the market item length minus 1, so this value represents the last index in the array, then we're going to loop back around to the first index, so index 0. Then we're going to return index. And for the skip backwards case, we're going to do something very similar, except we're going to decrement the index. And if the index is less than 0, then we're going to set the index to the last element in the market items array, and then we're going to return it. Awesome. Now let's create a use effect hook to handle the playing and pausing on the music player. So it's going to play the audio file if is playing is true, and if it's not, and is playing is not equal to null, which means that the DOM is not being mounted, then we're going to set it to pause. And we need to check that is playing is not equal to null, because if we try to access the audio ref when the component is mounting, we're not going to be able to, and that will cause our app to break. Alrighty, now let's go ahead and add the controls to the music player, like so. And then when the pause play toggle button is clicked, we update is playing with the opposite value. So if is playing is true, we set it to false. If it's false, we set it to true. So if is playing is true, we render a pause icon. And if is playing is false, we render a play icon. Awesome. And that completes the entire home component. Now, let's go ahead and import it inside of our app.js component, like so. Awesome. And now we can set the element attribute of the home route to the home component. Awesome. Now let's go ahead and return to our app and test out the home component. So click connect wallet. Sweet. And here is the music player on the home component. We have the name of the NFT, the identicon, and then the number. So 1 of 8. Awesome. Now let's click the play button. Pause it. Sweet. Then try out the back skip button. See if it returns the 8 out of 8 music NFT. Sweet. And it does. Then the forward button, back to 1 out of 8. Yes. Great. Okay. Awesome. That is so cool. Okay, now let's try to purchase one. the Icelandic arpeggio. Buy it for 1 ETH. Okay. Confirm the transaction. Sweet. And now it is no longer displayed in the music player. There's only 1 out of 7 available to purchase. Now, let's build out the My Tokens component so that we can view the Icelandic arpeggio NFT that we just purchased. So let's create a new file for the My Tokens component. mytokens.js. All right, sweet. So let's go ahead and paste in some boilerplate code for the My Tokens component. So for this component, we're going to load the tokens, so the user's tokens, in the same way we loaded all of the marketplace tokens on the home component, except we're going to call the get my tokens function on the contract instead of the get all unsold tokens. And we're going to use the same use effect hook to trigger the load my tokens function when the component is mounting. Now, the main difference between the user interface of the My Tokens component and the home component is that the My Tokens component is going to list all of the tokens on the page as opposed to displaying them in a music player format. So that means we need to create an array of audio refs to contain each of the tokens listed on the page. So let's go ahead and start building out the user interface. We're going to map through the My Tokens array. And inside of the callback for the map, we're going to display a card, and we're going to have it the associated NFT's audio. And inside the card, we will display the denticon for the NFT, as well as its name and the price that the user purchased it at. We're going to store the audio ref in the audio refs array at the same index that the associated NFT is located at in the My Tokens array. Now, below this card title, we're going to render the play pause button. But before we write the code that does that, we need to add a couple pieces of data to our state. Specifically, we need to keep track of which token in the My Tokens array the user has selected to play, as well as the previously selected token. The reason why we need to keep track of the selected token as well as the previously selected token is that we need to know which audio files we need to play and or pause anytime the user clicks on the play/pause toggle button for any of the tokens. So here's what that would look like. When we render out the play/pause button, when that button is clicked, we set the previous to the currently selected. Then we set the selected to the current index of the token in the My Tokens array. And we only toggle is playing if none of the tokens are playing, or if the selected token is equal to the token at the current index. So that way, if a user hits play on one song, and before that no songs are playing, his playing is triggered on, but if the user decides to hit the play button on a different token, then the is playing variable is not toggled. However, if the user then hits the pause button this time on the song that's currently playing, then it will be toggled. And if is playing is true and the selected token is equal to the current index of the token in the myTokens array. Then we render a pause button for that token. And then if not, then we render a play button. So inside the use effect, we're going to check if it is playing. And if that's the case, then we play the selected audio ref. And then we check if the selected is not equal to the previous. And if that's the case, then we pause the previous audio ref. And in the case where is playing is false, then we pause the selected audio ref. This logic makes it so that when a user is playing a token, right, and then they decide to play a different token, it prevents both songs from playing at the same time. It pauses the previously playing token and then plays the current. Alrighty, now let's go ahead and render out the resale form of the token inside of this card.footer. But before we do that, we're going to need to add a couple pieces of data to the state. Specifically, we need to keep track of the ID of the token whose input into their resale form has most recently changed, as well as the value of that input. And we're going to save that into resale price variable and resale ID variable respectively. So for the resale form, when the resale button is clicked, we're going to trigger the resale item function, which we've yet to define, passing in the item. And then for the form, whenever there's a change to it, we're going to set the resale ID, which will represent the ID of the item, and the resale price, the value inputted. And then we're going to manually set the value inside the input field to the resale price if the resale ID is equal to the item ID, and then null if that's not the case. So this will make it such that the user will only be able to set the resale price of one token at a time. Alrighty, now let's go ahead and define the resale item function up here. So first things first, inside this function, we're going to do some basic form validations. So if the resale price is set to 0 or the item ID does not match the resale ID and the resale price is a null value, then we return. All right, and if we pass those validations, then we first get the royalty fee from the contract. Then we convert the resale price from Ether to weigh units. And then we call the resale token function on the contract, passing in the item ID, price, and for the metadata, the royalty fee is the Ether value. And then we update the myTokens page by calling the load myTokens function. Alrighty, and that completes the entire myTokens component. Now let's go ahead and import it into our app component and then add it to the myTokens route like so. So let's go ahead and preview the myTokens page. Fingers crossed everything worked. Sweet. See if it plays. Nice. Now I'm going to purchase another MusicNFT. Okay. Confirm. Now let's see what happens when I play Spanish Moss. And then hit play on Esmanic Arpeggio. Sweet, so it automatically pauses Spanish Moss and plays Icelandic arpeggio when Spanish Moss is playing. And I click play on Icelandic arpeggio. Awesome. That's what we expected. Now let's try to resell one of the music NFTs. I'm going to resell the Icelandic arpeggio, the first one I bought, for a higher price of 2 ETH. Try to double my money. Click resell. Okay. Confirm. Sweet. Now let's see if it's in the marketplace. Awesome. And it's now listed for a price of 2 ETH. Sweet. Alrighty. Now let's build out the final component of our music NFT player project, and that's the My Resales. So that way we can view the Icelandic arpeggio token that we recently relisted on the marketplace. Alrighty, so at this point, you know the drill. Let's create a new file in the component directory. Name it myresales.js. Alrighty, so I'm going to paste in some boilerplate code. Now this resales component is going to display all of the tokens in the same way we displayed all the tokens in the My Tokens component, which is listed all on the web page. So we're going to use the same use effect to control the playing and pausing of tokens. And we're going to keep track of the selected and previous tokens, as well as the audio refs. So rather than calling getter functions on the contract to fetch the tokens that we need, we're going to use events to fetch the resale tokens. Now, the way we do that is by first calling the query filter method on the contract. Then we pass in a filter that defines the events we are looking for. And the way we create a filter is by calling the filters method on the contract. And then on the filters, we specify the name of the event that we are filtering for. And then we pass to it, for each field of the market item relisted event, the value that we're filtering for. And if we are not filtering for a specific value on an event, and if we are not filtering for a specific value on that events field, we set it to null, right? So in this case, the only field that we are filtering is the seller field. So we're looking for all the marketplace item relisted events where the seller is equal to the account. So the account that's connected to the app, which we have passed into this My Resales component. And next, we're going to fetch the metadata of each NFT and add that to an item object in the same way we did for the My Tokens and Home component, except we're going to map through the returned events. So because of that, we need to first fetch the arguments from the event. And after that, we then fetch the sold resale items by querying market item bought events with the seller set as the user. So we're doing this because in addition to displaying all of the items that the user has listed for resale, we're going to display all of the ones that have actually sold. And after that, we filter out the sold items from the listed items. Then we set the sold items and set loading to false. Alrighty, so we fetched all the data we need from the blockchain with this load my resales function. We don't need to create any functions that write data to the blockchain. This my resales component merely reads data from the blockchain. There's no writing to the blockchain. No, we can't make any transactions within this my resales component. So let's go ahead and focus on building out the user interface from this point on. So first things first, we check if the listed items length is greater than 0. And if it is not, then we display no listed assets. And if it is, then we map through the listed items array displaying a card to represent each token as well as an audio tag, just like we did for the My Tokens component, except the only difference now is that we're not going to include a footer that has a resale form. And right below the listed items, we're going to display all of the sold items, checking if there are any sold items. If there isn't, we say no sold assets. If there is, we map through the sold items array. And then we return a card for each token, kind of like we did for the listed items, except this time we're not going to have a play button for it, since all of the sold items will also be included within the listed items. So if we want to play a song that's within the sold, items, we can just play it in the listed items area. Oh, and I almost forgot, there's one last thing we need to include in this component, and that is the use state hook for the sold items. Alrighty, and that is it. We have finished the final component of our music NFT player application. Now, all we have to do is import it into our app like so, and then add it to the appropriate route like that. Okay, now let's check out the final product. So let's hit this My Resales navigation link. Hopefully everything works. Sweet, awesome. So the Icelandic arpeggio that we relisted on the marketplace, it is below this listed category. We play it, works, and it displays the price that we listed it at. Now let's go ahead and switch to a different account and purchase it. So let's go to the other account, this one. All right. Now let's refresh the page, connect wallet, go home. Okay. My tokens, none. My resales, none. That's what we expect. So let's purchase the Icelandic arpeggio. Buy for 2 ETH. Okay. Confirm. Complete. Awesome. It's in our My Tokens page. Okay. Now let's switch over to the other account. Refresh page. Connect wallet. Okay. Awesome. It's listed as a sold item. Sweet. Alrighty. That is it, everyone. We have built a full stack music NFT player app, a Web 3.0 Spotify clone. So congratulations, you've written a smart contract, you put it on the blockchain, you've written tests against it, we used IPFS to store the audio files, and React.js to build the client-side website you see here. So yeah, this is a robust, decentralized application that allows fans to purchase and resell tokenized songs from their favorite musicians. And so if you want to take this to the next step, there's a ton of things you can do to it. You can add a feature that allows artists to create a new music NFT collection for their latest album. You could also store each album's cover photo on IPFS and store the hash that points to it in the smart contract. And yeah, as always, please smash the like button so this video can get recommended to more people. And yeah, if you want to take the next step, eager to learn more about blockchain so you can land a high-paying blockchain development job, build your own project, or become a freelancer, head on over to dappuniversity.com/bootcamp to get started today. Alrighty, that's all I've got for this video. I hope you got a lot of value out of it. Until next time, thanks for watching Dapp University.